Welcome to another video from XF Motorsports. This video is going to be about oil pump gears, more specifically from the E55 and CLS55. So you might know about these cars that when you start them up, they make that annoying whining noise that comes from the front of the engine. It's actually coming from the oil pump gears themselves, and the reason is because Mercedes actually used flat cut gears for scavenging on the front of the pump, which is actually not the best design for scavenging, but a person actually reached out to me and he wanted me to redesign these gears and come up with a design that wouldn't make that noise. So yeah, I have come up with this design. It's a 3-lobe gear, a lobe type gear, much more appropriate for this type of use for scavenging. And actually the results with these gears were amazing. They actually flowed a lot better than these gears. They had a lot more suction power than these gears, and of course the noise is gone completely when I ran the pump with these gears. So yeah, this video is going to be about how I actually came up with this design, how I made these gears, and also testing them out and showing you guys the results. The reason why I was interested in making these gears is because I was actually working on a dry sump system for my car, for actually redesigning this stock E55 pump so that I could actually turn it into a dry sump system, and I was actually going to use gears similar to this one. Now I'm actually going to be using the exact same ones for my car as well. So basically adding multiple scavenging stages to it so that it can actually suck the entire oil pan dry underneath. And but that is of course a whole different topic, which I'm going to be talking about in a different video when I actually get to working on that dry sump. This video is just going to be about designing these gears, which was also pretty difficult actually, a lot more difficult than I thought it would be initially, because the clearances and a lot of other stuff had to match up properly for these gears to work. But it's a pretty interesting topic. I'll show you guys how I went through designing these gears and then actually making them and then testing them out in this pump, and yeah, quite a lot to talk about. Let's get into it. So I started off by taking one of these pumps apart so that I could measure the sizes inside them so that I could actually make gears that would fit inside the pump and work appropriately. For taking the pump apart, it's pretty easy, just 3 really long screws that are holding the pump together. Once they're removed, all the stages of the pump come apart. The pulley at the front is a press fit though, so you would need one of these pulley remover tools to actually remove it. Here's a look at the oil pump after it is all disassembled, and starting off by showing you guys all the components of the oil pump and why it's actually designed this way. So a weird thing about this oil pump is that it actually has 3 stages rather than just one, which is what your regular cars have. And the way it works is that this front stage, which these 2 gears go at this part, this is the front stage of the pump. This is just a scavenging stage. It's just sucking oil from this pickup, and it sends oil from this tube all the way to the back to the main oil sump, which is at the back of the car actually. So there's 2 oil sumps, one oil sump at the front, one at the back. The smaller one at the front is just like a dry sump. It's always being sucked dry by the scavenging stage. The back one is the main part, and the pickup tube that goes from the back part actually goes to this pipe, which links over here. And these 2 gears actually, when you look at it, they're actually linked together. They do the same thing. The reason they have 2 of them, one larger one and one smaller one, is just because they added this extra section on the pump for bigger engines, V8s and AMG models, and other models. I believe the V6 ones only have 1 gear because they don't need that much flow. So basically, yeah, these 2 gears form the main stage of the pump, which actually flows oil to your entire engine and actually makes the oil pressure that your car needs. But this front sump is just a scavenging stage, and the reason why these oil pumps are so noisy is because they're actually using the same gears that they're using for the main stage also for the scavenging stage, which is not really a good idea because usually scavenging gears are not straight cut gears like this. And what happens is when these gears start sucking in air, they make an awful lot of noise, and they also cause all that foamy oil to flow through the pump, which is not good for preventing oil starvation really. So yeah, what I'm going to be doing is that I'm going to be redesigning just this front part of the gears. I'm going to be making proper gears like you usually see that are meant for scavenging, lobe type gears, and the rest of these gears I'm going to leave them the same. So yeah, let's start off by getting into the design. So for designing the gears, I started off by measuring the pump and seeing what size to actually make the gear so it would actually fit this pump. And this was not a generic design taken from some other pump, it was actually a design that I came up with for this specific application so that it would displace fluid in a much smoother way and yeah, just work better for this application. So it took a bit of time getting the design sorted, but I think it was a really good design at the end. So after going through a few different designs, I've actually come up with this design that I'm planning to make the gears. It's a 3-lobe design, and the reason I think this is going to work really well and not make any noise at all is because, well, first of all, the way these gears move together, it's actually pretty cool. Like, it looks like the gears are actually touching each other and one gear is pushing the other, but actually, like, both these gears are moving on 2 shafts that are already going to be rotating on equal speeds, and well, there's always a little bit of a gap in between the gears, and they're actually never touching each other. They always maintain that little bit of clearance in between, which is why these gears can actually be made out of aluminum, and they still will never wear out just because they're not touching and there's no friction in them. Explaining how they actually work, I'm actually going to explain like how these gear pumps actually displace oil with this little section of the Mercedes oil pump. So basically, yeah, how it actually works is this pocket over here is the inlet, this pocket is the outlet, and you can imagine when these gears will spin like this, what they're doing is that they're actually taking all the oil that is in between all these gear teeth and they're pushing all that oil to this outlet. And the reason why the oil from the outlet doesn't go back into the inlet is because when you look at what happens in the middle, the gap almost gets closed completely, so all that oil that is in between the teeth, it still has to stay on the outlet. There's a little bit of a gap in this one, which is why it's not a really efficient design, and that little bit of oil does flow back into the inlet, but still the amount of oil that is being flowed to the outlet is still much more than the oil that is going back into the inlet, which is why it still flows oil to the outlet and it still makes oil pressure. But of course in this design there is no oil in the middle that is flowing back to the inlet, and also the total amount of oil that is stored in between these 2 lobes is much greater than the displacement. So basically these gears can displace a lot more oil in one rotation than these gears will displace, which is why these gears will actually flow more. They will make less noise because they're not physically touching each other, and also they displace oil in a much smoother way than these types of gears. So now that the gears are designed, next it's on to actually making them on the CNC machine. And the way I'm going to make them is that I'm going to make them in sets of 4 just so that I don't have to work too hard making each gear individually. So, well, actually playing a quick simulation of how the machine is actually going to cut these gears. It's gonna start off by making these holes in the center, which these holes have to be a really exact radius because they have to get press fit onto the shaft that is going to be spinning these gears, and the press fit has to be tight enough so that the gears don't come loose. And yeah, it has to be a really exact diameter for them to work properly. After that, it's going to face the top side of the gears, and after the facing operation, it's going to clear away all the stock so that it can form like the 4 individual gears. And after that, the last step is finally going to be the finishing passes. The reason I kept finishing passes separate from that is because the outer side of these gears, it has to be really exact. It's a really precise shape so that the gears can move along together and have an exact amount of clearance in between, so that it's not small enough so that the gears start hitting each other when they get up to temperature, and it's not big enough so that it doesn't make any oil pressure. So that's why this shape is actually a really specific shape, and it needs to be machined really specifically for the gears to actually work. And of course, once all this is done, next it's going to be time to actually cut these gears off from the rest of the aluminum, flip them over, and then face the backside of these gears to actually form the individual gears that are going to be used in this pump then. So after that, it was on to the CNC machine to actually make the gears, but this was actually much more difficult than I thought it would be, because the first set of gears I made, the press fit was a bit too tight and the gears would get damaged while putting them on the pump. The second set of gears I made, I fixed all those mistakes, but I had another mistake in the design. When I actually put these gears in the pump and spun it up to speed, what I found out was that the gears in the pump had a bit of backlash, which meant that, like you saw in the design, these 2 lobes were not actually moving at constant velocity with each other, they were actually shaking back and forth a little bit as well, which meant that they actually started hitting each other because the clearances I kept were a little too tight. So what I found out after a bit of torture testing running these gears at high RPM was that the aluminum started melting away from the points it was actually hitting each other from, and then finally I had to go back to the design, open up the clearances a little bit from those parts that were hitting each other to compensate for the backlash in the gears, and then finally the gears worked properly, and they didn't touch each other, and they actually performed really well. Here's a look at the gears after they're all machined, and took a couple of attempts getting these right. Of course, the first set of gears didn't really work out because the press fit was so tight that the whole gear used to get damaged before you would get it on the shaft properly. So these ones I did open up the board just a little bit, and I also tapered it so it's bigger from one end, smaller from the other, and because of that now it's easier to press fit on and also remove if you have to remove it. So now for assembling the pump with these new gears, it's going to be a little bit different than how this pump is put together, because, well, the way all these gears work right now is that these two gears are press fit, so they both are like press fit onto the shafts, they don't move, but these two gears are completely free from the shaft, so you can see they move freely, and then these two gears are the ones that drive these two gears because this one actually has a key on it that doesn't make it spin free from the shaft, and then this one has this shape at the top that also doesn't let it spin free from the shaft. So that's how it all works together. But the thing about these gears is that since we're going to be using these gears on this part of the pump, this front stage is actually the stage that is moving the other shaft so that both these shafts actually move together. But if we get rid of these two gears, then of course the two shafts will not spin together because these two gears are free. And we can't just press fit these on and still expect it to work, because these two gears, the lobe type designs, they don't one gear can't spin the other the way this whole thing works. It's just they have to be on two shafts that are already driven at the same speed, and that's how these gears will function properly. So basically, in order to make it all work, what I need to do is that I need to get rid of these two gears, which are free on the shaft, and I need to basically move these press fit gears over to where these gears are located right now, and luckily I can do that because they are the exact size and they work the same way pretty much. So and then I need to press fit these gears onto this shaft, and but first I need to put this part of the pump on before press fitting these on, and once that's done, then I can put the rest of the pump back together and everything is going to work. I have this other pump over here, which is the broken pump from my older E55. I'm thinking of using this pump as assembling this one back together with all the stock gears, and then I'm going to make like a testing thing for this so that we can test both these pumps together and see what noise differences we get with these gears and then with the regular straight cut gears. So it's going to be pretty interesting to find out. Let's put this together and see how it goes. So for assembling the pump with these gears, first I started off by moving these factory press fit gears to the second location rather than them being at the first location. So for this you need to remove this keyway that's already installed on the second location, and then you need to mark a point from the top which is 30.2 millimeters away, and you need to actually move these gears to that line, and that's going to ensure that they're at their proper place. After that, it's time to put these two shafts in one of the stages of the pump where they go, and after that you need to press fit the lobe type gears from the other side. The reason you need to actually put the stage in first is because once you have gears on both sides, you're not going to be able to install or remove this stage later. For putting these gears on, I was using one of these screw tools because I didn't have a hydraulic press, but having a hydraulic press would have made this job a lot easier. But once the lobe is almost compressed all the way down, just use a feeler gauge of 0.062 millimeters. And right when the feeler gauge starts becoming tight, that's when you should stop pressing the gears down. Here's a look at the pump after one gear is installed, and at this point just make sure that everything is spinning freely, nothing is binding or anything, and now is actually the difficult part, putting the second gear on, because the orientation of these gears actually has to be a certain way. So yeah, if this gear is pointing like this gear needs to be pointing exactly like this, and since this is a press fit, all that actually has to match before press fitting it on, otherwise these gears are not going to spin properly on each other, and basically they're going to bind. So at this point I'm just going to line them up really carefully just by looking at them. And then once this one is press fit on, again I'm going to make sure that it's the clearance from the bottom is 0.63 millimeters. You can just stick this feeler gauge in between this and the bottom and make sure that the feeler gauge can move freely. Right when it starts tightening up, that's when you should stop. And at this clearance, everything should be working properly. This clearance is basically going to ensure that the gear is nicely centered in the pump and everything will work properly then. So yeah, next it's time to press fit the other one on, which is a little more difficult, and let's hope I get this right the first time, because otherwise I'll have to take this back off again and then rotate it and put it back on. So for installing the second lobe, I had to use my vise because this one wouldn't fit my tools since now the other shaft was in place, but still it worked out. And the important thing to check at this point is that once you press with the other one, make sure that both these gears spin freely and at no point should they be hitting each other. And also make sure that when you position the lobes like this, make sure that the clearance around the lobe is like perfectly even all the way. That would mean that you have phased these two gears properly. If they're not phased properly, then this clearance would not look like that. The gap would be getting tighter at one end or the other. After that, it was just the regular process of assembling the rest of the pump, which is fairly straightforward. And after that, of course, it was time for a little bit of torture testing, putting these gears in the CNC machine and spinning them up to really high RPM and only lubricating them using WD-40 and finding out what the results were. Of course, the first few set of gears did not fare too well on this test, but after getting everything right, even after spinning these gears at high RPM for so long, taking the pump apart, there was no wear on these gears at all. They weren't even touching each other, so that was the result I wanted to see. Okay, so after a million attempts, I have gotten these gears to somewhat of a point where like the pump spins freely, doesn't make too much noise, and now it's time to actually test out what sound the gears will actually make when you put them in oil. And for this one, I won't be doing it in my CNC because first of all, I can't mount the pumps horizontally in the CNC, and secondly, I don't want to put oil in that machine because if something messes up, it's going to be a massive hassle cleaning up that oil and everything. So what I'm going to do is I'm going to fill up oil in this thing, and I have connected these oil pumps to this impact gun, which is going to be able to spin it at fairly high speed, at least more than idle speeds, which is when the pumps actually make that whining noise. And what I'm going to do is first I'm going to put this crappy pump with the stock gears in the thing, and I'm going to try to replicate that same noise that these gears make at startup, and then later on I'm going to put this pump with the same thing, try to spin it at the same RPM and see what noise we get. And I'm really hoping that that whining noise goes away with this pump, because if it doesn't, then I'll have to kill myself at this point. So I decided what better oil to waste for this test than Royal Purple, since no one likes this oil at the shop. So yeah, this was new oil, but it's just colored purple for some reason. That's why it looks like old oil even when it's new. After that, it was time to put the Mercedes pump to the test first and see what noise we got from that one.
Is that on the screen? It's screaming for help.
Let's check our one.
Crazy. Let's see what noise yours makes.
Nah, this is the nervous one. Ooh, whoa, the what? Look at that.
Big difference, no?
Yeah. That's amazing. That's a big difference. Okay, so after testing these two gears out, I would call that a massive success. With this pump, that stupid, annoying, whining, flat cut gear noise is completely gone. It's actually really quiet, and it flows a tremendous amount more. Like there's a really big difference in flow. There's a really big difference in suction. Like when you have only half this in oil, it has so much suction that it can still suck up a ton of oil and throw it out. Whereas with this one, if only half the thing is in oil, it barely sucks in any oil. So there's a really clear difference there. There's actually the biggest difference is in noise, that even when this one you take it out of oil completely, there's almost no noise coming from the pump at all. It's really quiet. And with this one, of course, it's a whole different story. It's a really noisy pump when you take it out of oil. When it's in oil completely, of course, then there's no noise, but as soon as it comes out of oil, there's an awful lot of noise. And of course, the application that it is being used in, it is almost always not being submerged completely in oil, because it's being used as a scavenging pump. It's sucking oil completely dry from the front sump and it's throwing it back to the sump at the back. That's why I was testing. I was pulling it out of the oil and seeing what type of noise it makes when it's not in the oil completely, because that is the application that it's being used in. Also, there was a big difference in foaming, how much this one foams up the oil and how much this one foams it up. So yeah, with these gears, there's a definite difference. They don't foam up the oil nearly as much as the stock ones do. So that's again another benefit. And of course, there's the reason why people use this style of gears in any dry sump application. And I guess the only reason Mercedes didn't do that from the factory was just to save cost. They just copied the same gears they were using for the main stage and put them on the scavenging stage as well. But yeah, that's gonna be it for these gears. Took a lot of effort getting these right, but it's amazing to see the results, how well it's actually working. So that's going to be everything for this video. Really happy with how these gears turned out and how well they worked at the end, and I cannot even wait to actually test them out in my own car when I make the dry sump system for this one. Yeah, if you want to buy these gears, they are going to be on the XF Motorsports website. Two of them I'm of course going to be shipping really soon for the person who actually requested this. But yeah, other than that, there's also a few more really cool videos that are going to be coming up for you guys. One is for this really long-awaited 300ZX, Sebastian's car. The engine is finally back in the car. We're almost getting there to the point where we can actually hook everything up, start this car up, take it to the dyno, and hope that it actually makes good power. Other than that, though, there's actually some really cool winter projects that are coming up really soon that you guys definitely won't want to miss out on. So yeah, stay tuned. This is everything for now. Thanks a lot for watching. I will see you guys in the next one.